Hello and welcome back. Today's lecture is on functions. It's a brand new question I wrote this morning. Don't worry about question 7. It's not question 7. It's just it's going to go into one of my synoptic papers. I believe it's on paper X, which has not been written yet. So let's have a look. It's a little bit unusual. I had a little bit of inspiration. There's some obvious, straightforward stuff to start with. So, but there's a couple of unusual bits later on in the question. So let's get going. So first of all, they're defining a function f. F of x is defined as some kind of reciprocal, and with the usual sort of situation, all real numbers allowed except, of course, 1, because obviously it will make the denominator infinite. So rather 0, in which case it will make the function undefinable. The first thing that the question is asking, part A, is to find the inverse function f to the minus 1 of x, which is just standard methodology. I'm just going to go very, very quickly through this bit. Write the f of x as y for simplicity. Make x the subject, which has many steps as necessary. So we're getting something which looks like that. And just collect all the x terms on the left, the non-x terms on the right, factorize the x, blah, blah, blah. Y minus 2 is equal to y plus 1. So x is y plus 1 over y minus 2, and therefore f to the minus 1 of x is just x plus 1 over x minus 2. And that was the part A. How many marks would that be? Probably 3 marks, 3 generous marks, in fact, in an exam. I don't think you'll be getting more than that. Now comes the next bit, which I'm going to write. So let's this is already given. What does he actually say? G of x equals question mark. Find the function g so that f of g of x is x squared plus 2. So, so we need to find the g. So when we do f of g of x, the answer that we're going to get is x squared plus 2. Where do we go with this? This part A is actually very useful. So I'm going to write it up here for reference. And let's see how we can use it. So here it comes. And let's clear the rest of the board. So let's think about how we're going to answer this problem. We know the f, it's here, and we want to find a function g, so when we compose f of g of x, we end up with this. This is how you do something like that, or one of the ways. F of g of x, we want it to be x squared plus 2. I'm going to compose, I'm going to use a different color pen to actually illustrate what I'm doing. I'm going to compose both sides of this equation by f to the minus 1. So from the left and from the left. Now, why is that? Is the next question to ask. Of course, you say, okay, what possessed you to do this? Well, the reason that possessed me is now when you're looking at this combination of functions, f to the minus 1, f, g, I'm looking at this bit here. These are inverses of one another. They appear here. So they will annihilate each other, basically. They will cancel each other out. So if you look what happens on the left-hand side of this equation, the f to the minus 1 and the f, you can call it cancel. And of course, it will give me g of x, which of course is what I'm trying to find. And g of x is f to the minus 1 of this. What does that actually mean? It means take your inverse function, which we have it as f to the minus 1 of x here, and replace wherever you see x here with x squared plus 2. So This will now be x squared plus 2. Make sure you follow where these bits are coming from. And x squared plus 2. I will pause to actually see it. Okay, so this is the f to the minus 1, which I'm looking at here. And at the moment, the argument of that has been replaced. Instead of x, if I have x here and here. If I have x squared plus 2, it's going to be x squared plus 2 and x squared plus 2 in there. And of course, this will tidy up a little bit. I deliberately put a 2 so it cancels that 2 in there. So we got x squared on the denominator, x squared plus 3, which you can leave like that, or perhaps I've done this deliberately, so I can write that as 1 plus 3 over x squared. And that's the answer to this particular one. Is that difficult? Perhaps it is if you haven't quite come across it or you haven't seen anything like that before. It's a little bit different. Okay, let's have a look at the third bit. The third bit, it says, determine now a function h, a third function. So the h of 2x minus 1 over x plus 1 is x squared minus 1. Okay, I'm going to write it down again here on the side. Let's clear this space. And let's see what is actually asking us. Do we need that? I don't think we actually need part B. So I'm going to wrap it off. So it's telling me to do the following. Okay. A new function, h, which I need to find it, h of x equals question mark, has the following property. The h of 2x minus 1 over x plus 1 should give me x squared minus 1. What is the function? Okay. This type of question, I don't think, I could be wrong on this one. I've actually seen at A level, or maybe have seen it's such a long time ago, I've forgotten it. The first time I came across things like that was in fact at my degree. Not because it's degree level, it's because the manipulations required, I think it was some kind of partial differential equation that was solving, required you to do something like that. It's not actually hard. So let's have a think about how we're going to do that. We would really like to have here just a single letter, x, u, y, something, h of y, h of u, h of x. At the moment, we got a mess. So the first thing that we're going to do with something like this is we're going to say, you know what, let u be all of this. And let's see how we're going to take it. So basically, we replaced all of this with u. And of course, this is going to be a h of u now, so we have to have u's on this side. Therefore, because now we have x's on the other side, we need to make x the subject here quite clearly. So times it across, xu plus u is equal to 2x minus 1. Where shall we move stuff for this particular one? Maybe a good idea to say 2x minus ux, taking that to the other side, is equal to u plus 1. And then factorize, we try to make x the subject, 2 minus u, u plus 1. And now we have x is 1 plus u over 2 minus u. So we have two equivalent statements. U is equal to that in terms of x, or x is that in terms of u. Look what we've done so far. We have an h of x. In the argument we have x's, and of course on the other side we have x's. Now we have u's on this. Why we have u's? Because we call this u. Therefore, the x's on the other side need to become u's. But of course, we know what x stands for in terms of u. So it's going to be 1 plus u, 2 minus u, all squared. That's my x squared minus 1. And this will simplify. Let's square it out. 1 plus 2u plus u squared. Square your denominator is going to be u squared minus 4u plus 4 minus 1. Can we do better than that? We can, I guess. Do a single fraction. So we got u squared minus 4u plus 4. And on the top of that, we will have u squared. I'm writing that bit first. plus 2u plus 1 minus all of this is going to be minus u squared plus 4u minus 4. The u squareds will cancel, and I'm going to end up with 6u minus 3 over u squared minus 4u plus 4, which again we can write it as a 2 minus u or u minus 2 all squared, but we can leave it like that. But don't forget, just for technical purposes only, the question wants us to write the function in terms of x. So at the moment what we got is not that it matters. We have the h of u, the function h should be doing this. And if you want to rewrite it back in x, of course you can, it hardly matters, it's a dummy variable. So h of x is of course 6x minus 3 over, and you can check these compositions afterwards. I mean, if you want to check, does it do what is being claimed that it does? Of course it does. And you can check your work that it has been done correctly. Okay, this was from a new question, a little bit unusual. My channel is known for the unusual. I don't really put a lot of standard stuff. I'm trying to kind of like following the theme of my papers and my resources, which is the kind of enrichment material and unusual to help the very bright in mathematics and inspire. Okay, I'm going to be signing out. I'll see you real soon. Okay, bye for now.